Good morning, my YouTube viewers. It's Crystal here. Basically, if you watched my last video, we used Python to create an agent to perform an analysis on a waste CSV file. That file had originally been an Excel file, and I converted it to a CSV file and put it in my Google directory. And what that did was that enabled me to analyze a CSV file using an AI agent that we had made in Python. And what I'm doing in this video is I'm making an AI agent in R. And we're going to analyze the same CSV file in R that we previously had analyzed in Python. So before we go any further, then what we will do is we will talk about exactly what an AI agent is, because at the last year or two, there's been a lot of talk about AI agents, and people are quite often making AI agents on their own, because you can use no-code or low-code programs to make AI agents. But I just made an AI agent initially in Python, and now I'm doing it in R. So you can make your own AI agent, and you don't need to use a program to make an AI agent if you don't want to. So an AI agent is a software program designed to interact with its environment, collect data, and perform tasks automatically to achieve specific goals by humans. These agents can make rational decisions based on their perceptions and data to produce optimal results. So this is done in R. So one of the things that the differences between R and Python is that Python is a general purpose programming language, and if you want to do anything special, then what you need to do is you need to import libraries. But R is a programming language that was designed specifically with statistics in mind. So if you want to perform statistics, you can use R using its inbuilt functions. And I've created this program in R using Google Colab, because you can write a program in R. In Google Colab, if you go to this link right here, that will open you up a blank Jupyter notebook in R. So that's what we've done. So I'll leave this on the screen for you. So if you want to have your own Jupyter notebook in R, you can type that web address into your browser, and that will give you a Google Colab Jupyter notebook in the language of R. So now that we have opened up our Google Colab, and we're in the R programming language, then what we want to do is we want to make the agent. And if you watched my last video was in Python, and we made a class, and within the class you had several functions. But in this particular video, using R, we're just going to define the function. So your waste analysis agent is your function, and it's going to accept the file path as input. So in some aspects, I think that if you want to do an AI agent that is primarily analysis, then you want to use just R's inbuilt functions, then it might be easier to make an agent in R than it is in Python. But you will need to experiment with both R and Python and find out which ones that you like better. So after we have defined our agent, we define our df, which is your data frame, is read.csv file path, string s factors equals false. And the thing about the difference in this respect, the difference between R and Python, is that R, read.csv, is an inbuilt function, whereas Python, you have to import the library pandas, and then pandas will read the CSV. And then we do clean call of names. So names df is to lower G sub, and you're going to convert your space into a dot, and you're going to use the names df as the data, what you're going to convert the name to, and then you print names.df. And so what I did is that's the way that I was able to get it to work. And then you print your names.df, so that will tell you what the names are. And now we're going to convert the date. And again, that's an inbuilt function as well. But if you wanted to do that in Python, you would have to do that in the pandas library and use the date time library in pandas. So df $date is sdate brackets df $date format day month year. Now we're going to summarize the waste data. So cat is like another word for print. So you're going to print the summary by waste type. Type summary is aggregate, bracket C behind. And so that means you're going to put them together. Weight dot tons, cost. And it's going to be with type of waste. Then data is your df, and then you're going to sum it. So you're going to total all the numbers. And you're going to print type summary. And now we're going to do a summary of the location. So again, you're going to print summary by location. Location summary equals aggregate, brackets C behind, brackets weight.tons, cost. And then you're going to mix it with location, and the data is the df, and you're going to sum it. And then what we're going to do is we're going to detect the anomalies. So you're going to print anomaly detection. So df, cost per ton, is df $cost divided by df $weight.tons. And then average cost equals mean, brackets df $cost per ton, brackets na.rm equals true. Anomalies equals df square brackets df $cost per ton is greater than average cost times 1.5 square brackets. And then if in row anomalies is greater than 0, then you print anomalies, square brackets, C, type of waste, location, cost per ton, and else you're going to print no significant anomalies detected. Now we're going to plot the chart, and again, we're going to be using R's inbuilt functions to do that. And the difference between R and Python is Python does not have any inbuilt functions to actually print pictures. So in Python, you have to use the library matplotlib to print pictures, whereas in R, you just do it automatically. So you print generating charts, and it says a bar plot. So you're going to make a bar plot, type brackets, type summary, $weight.tons, names.arg equals type summary, $type of waste. Main equals total waste by waste type, brackets, white lab equals weight tons, comma, column color equals steel blue. And then we're going to create a second bar plot, brackets, type summary, $cost, comma, names.arg equals type summary, $type of waste, comma, main equals total cost by waste type, comma, white lab equals cost in pounds, comma, color equals orange. And now we're going to print recommendations. So you're going to print recommendations, and it's going to be expensive type equals type summary, $type of waste, square brackets, which.next, type summary, $cost, brackets, square brackets, and you're going to print focus on reducing, comma, expensive type, comma, waste as it has the highest cost. And then we're going to do usage. So usage, what usage means is we're going to call up the function. And then so we're going to call up the function, and we're going to accept the path to the spreadsheet to actually run the program. So here we go through the code. So it says type of waste. These are your names, your column names. It's type of waste, location, date, description, container, size container, weight, tons, and cost. And then you do your summary by waste. So your summary by waste is going to be clinical and domestic. So you have two types of waste. And then the total waste for clinical is 9, and the cost is 6165. The total waste for domestic is 4.45, and the cost is 1800. So now you're going to do a summary by location. So you've got 4 locations, being Bracknell, Reading, University, Windsor, and then it breaks it down into weight and cost. And now we're going to do anomaly detection. So the anomaly detection is going to be clinical and Reading, and it's going to be cost per ton. And one thing that it didn't include was what type of waste, what the category of waste it was. It did not actually include that in this agent. So if you wanted to, you could amend the program to include the category of cost if you wanted to. And so now what we've done is we're generating the charts, and this is again is an input function with R. So you've got your clinical and your domestic. So you can see that your clinical waste is about twice as much as your domestic waste. And then so now we generate another chart, which is the cost. So you can see that the cost of the clinical waste is much more than the cost of the domestic waste. And the reason why is because you have to use, it takes a lot more to dispose of clinical waste than it does domestic waste. And then we also had recommendations. It says focus on reducing waste as it has the highest cost. Okay, so yeah, waste, it costs a lot of money to get rid of waste, and that's why waste is a big deal, and a lot of organizations are looking at ways that they can reduce their waste by recycling, and using landfills and things like that. So that concludes this video where we have made an agent in R. And as you can see that this agent in R, it certainly didn't do everything because it didn't include the category of waste, because you can see here, it says type of waste, location, date, description, container. So we could have, in order to be more specific in the anomalies, if it had included the description, then you would know a little bit more about what the what type of waste it was, because the type of waste is either clinical or domestic, but you also have a description of waste. So like it could be treatment or incineration or offensive waste or dental amalgams or recycling. It could be a number of things which were not included in this agent. But you can modify the agent to include that data. So it says anomaly detection. So when we get into an anomaly detection, it says print type of waste, location, cost per ton. So you could amend it. So after location, you could amend it to say description, and then that would give you a little bit better description of the waste that you're actually trying to dispose of. So that concludes this video. If you like my video, please like and subscribe, and I will be making another video for you on agents very soon.